All right, so good morning, good afternoon, or good evening. This is Dr. Franklin from the Department of Psychology, Norfolk State University, just providing you a brief video to answer some of the commonly asked questions or frequently asked questions as it pertains to hypothesis testing. So it's important that the context is understood. So within this video, when we talk about hypothesis testing, we're talking about it in the context of normal deviate z-scores. Okay, so taking a sample mean, converting it into a z-score, which is actually a standard error of the mean unit, so that we can get an assessment of extreme differences or the likelihood that the sample mean is very close to the population mean. Okay, so these are some frequently asked questions that I'll answer for you, and I hope it helps you as you're learning and building your acumen about hypothesis testing. So, first question is, how do I select a critical region boundary? Well, first, you're going to need to know whether it's a one-tailed test or a two-tailed test. Okay, and this is information that will be given to you in the problem that you are solving. So it'll explicitly say one-tailed test, two-tailed test. It'll tell you which route to go. If you're doing your own individual research, you'll have to make the decision as to whether or not you just want to assess for differences and you're not sure where those differences are going to lie. It's going to be in one of the tails of the distribution or both of the tails of, or the other part of the distribution, and you're not sure where it's going to go, or if you are pretty confident that it's going to be in one tail based on research literature that you've perused and processed and thought about deeply. But you're going to need to know one-tailed test or two-tailed test, okay? And that information will be given to you in the problem. You'll also need to know the alpha level. Now, keep in mind the alpha level, this little symbol here, that's what it represents. The alpha level is the amount of error that the researcher will allow in the study, and this will vary based on the impact and the practical implications that the results of the research study will have to everyday folks living everyday lives. Okay, in the problems that you're going to complete in class, some of the typical alpha levels are 0.05, 0.01, 0.001. So this is the likelihood that the researcher is wrong. Okay, so 5%. So we just take 0.05 and convert it into a percentage to get the proportion that is going to be used as a critical region boundary marker within your sampling distribution of the mean. Same thing with 0.01, same thing with 0.001. So alpha level, the amount of error in the study. And these proportions, guys, are relevant this way. So 5%, if you had a problem that's at 0.05 equals 5%, and you were doing a two-tailed test, what that means is that there's 2.5% that's going to be marked as a critical region boundary in one of your tails, and 2.5% earmarked as the critical region boundary in this tail. Okay, so 2.5 plus 2.5 gives us 5%. Okay, and this critical region boundary is a marker that allows you to say that if your calculated z-score exceeds it, it's a significant difference. Okay, it's far away from this population mean, and that very well likely may be due to the treatment, or maybe due to just the sample and typical characteristics of it. Okay, so how do I select a critical region boundary? By taking into consideration if it's a one-tailed test or a two-tailed test, and then based off of that, taking into consideration your alpha level. And there are certain z-scores that represent these particular alpha levels for one-tailed test as well as for a two-tailed test. Okay. So they commonly are, and I'll go ahead and write those out, plus minus 1.96, and this is for two-tailed test, plus or minus 1.96 for 5%, plus or minus 2.58 for 1%, and plus or minus 3.30 for 0.1%. What does that mean? Well, if we go back to the sampling distribution of means, we'll realize that standard error of the means line the bottom of this distribution. And this plus or minus 3.30 is sort of like standard error of the mean that will serve as the boundary for this. So if you had a two-tailed test and you were calculating the statistic, and it was, once you got done to normal deviant z, it was higher than 1.96, positive or negative, then that means that you would indeed reject the null hypothesis, accept the research hypothesis. So that's for a two-tailed test, and later on I'll talk about z-scores for one-tailed test. What two pieces of information do I need to select the critical region boundary? Well, we've already kind of talked about this. You need to know if it's a one-tailed test or a two-tailed test. You also need to know the alpha level. Okay. So you'll need to know a combination of these two things. You'll have to select one. Okay, so one tail to two tail, one or the other. Alpha level, is it 0.05? Is it 0.01? Is it 0.001? And then from there, you'll know to go with a specific normal deviant z-score that represents your critical region boundary. Okay. And for one tail, let's go ahead and write that out. For a one tail test for 0.05 alpha level, you can go with a normal deviant z-score of 1.64, and then for 0.01 you can go with 2.33. Now, something to keep in mind is that if you're going with the one-tailed test, that means you have a directional hypothesis. You're indicating that your calculated z-score will most likely either fall on the positive end of the distribution or the negative end of the distribution. So these z-scores as critical region boundaries are not necessarily positive and negative. You have to select if it's positive or negative based on what's given to you in your problem. Okay, so if your problem is talking about a significant increase of a certain dependent variable, you'll know that your critical region boundary marker in terms of the z-score that represents the proportion of error that you're allowing in the study, which is related to the proportion of error that you'll have within the tails of your distribution. Extreme scores, right? You'll know that that needs to be positive. Needs to be positive. If it's talking about significant decrease, then you know it needs to be negative. So you could very well have a one-tailed test in which the critical region boundary marker as a z-score is positive 1.64, and you calculate a normal deviant z that's negative 1.65, and it not necessarily be hand in hand with your research hypothesis, right? Because it's you calculated a negative z-score, but it was predicted that it would be in a positive direction. So while it's significant because the absolute value exceeds that 1.64, it's still not in the indicated direction. So you could say something to the fact that it was significant, but it wasn't in the specified direction. Why is the critical region boundary important with hypothesis testing? It's important because it determines whether you accept or reject your hypotheses. It also delineates extreme scores from typical scores. Okay, so this is the critical region boundary marker. And if we get a sample mean converted into a z-score that's way out here, we know that this is an extreme score as opposed to one that would normally occur if the z-score was indeed near the center of the distribution. How are the z-scores that are used for critical boundaries obtained? Well, they're obtained from the unit normal table, and an easy way to find the z-scores associated with certain proportions in the unit normal table is by looking in column C as it pertains to your unit normal table or proportions in the tail, and then thinking about whether or not you have a two-tailed test or one-tailed test once you have your alpha level. If you know that you have a one-tailed test, then you could just look for the proportion in the tail of 1% or 5% or whatever you're working on, and look at the z-score that corresponds with that, and that would be your critical boundary region marker. However, if you had a two-tailed test and it was 5% alpha level, it's necessary to divide that 5% into two different proportions because, again, you're working with two tails. So upon doing that, you should look up that divided proportion, and that will give you the z-score that corresponds with 5% total for a particular distribution. So those z-scores are obtained using the unit normal table and everything that we know about the unit normal table. How do I make a decision in regard to accepting and rejecting hypotheses? So another really good question. All right, and we'll use two different hypothetical examples to lay out the answer to this question. Let's say you calculated a normal deviate z. So you know the formula by now. Mean, sample mean, minus population mean over the standard error of the mean, right? Let's say you got positive 1.99. Let's also say hypothetically that your alpha level was 0.05, 5%, and it was a two-tailed test. That would mean that your critical region boundary would be, if you were thinking plus or minus 1.96, you're correct. Okay. So how do I make a decision in regard to accepting and rejecting the hypotheses? It's fairly simple with a two-tailed test, because with the two-tailed test, all you have to think about is the absolute value of your calculated z and the absolute value of your critical region boundary. Okay? If your calculated z exceeds your critical region boundary, so if it's higher than 1.96, you would reject the null and accept the research hypothesis. Why? Because you have a significant difference. Your difference is way out here in the tails, right? And it doesn't matter if it's positive or negative. Even if this was negative, you would still reject the null, accept the research hypothesis, because still an extreme score. It's just in the opposite direction. Okay. So with a two-tailed test, guys, it's fairly simple. All you have to do, whether your score is negative or positive, all you have to do is ask yourself, does my normal deviate z exceed my critical region boundary marker? Okay, if it does, you know what you do. You reject the null, accept the research hypothesis. If it does not exceed it, if it's lower, then you do the inverse. So you'll accept the null and reject the research. Okay, so if it's, let's see if we can get that in there. If it's higher, accept research. And you guys can't see that. But if it's higher, accept research. If it's lower, reject research. Okay? Fairly simple. Now, this would change if you had a one-tailed test. If you had a one-tailed test, you'd have to take into consideration now the direction of your critical region boundary marker. Okay, so let's say we had a one-tailed test. Alpha level was 0.05, and the example said something about a significant decrease. That would mean that your percentage would be on the negative end of the distribution, and your z-score would be, as a critical region boundary marker, it would be a negative 1.64. Let's say you got the same thing, which you got above. You got a positive 1.99. Okay, so this is different because you are looking for a significant difference in a certain portion of the tail, in the negative part. You got a positive number. So even though the absolute value exceeds that number, and it is a significant difference, it is technically in the opposite direction. So it wasn't in the hypothesized direction. Therefore, I would still be inclined to one, maybe you wouldn't necessarily reject the null hypothesis because there is a significant difference. So you would still reject the null hypothesis because there's a significant difference. But in terms of what you do with the research hypothesis, you'd have to place the wording a bit different. So you would say that you're not accepting the research hypothesis with the caveat of there was a significant difference, however, it wasn't in the anticipated direction. Because if you were looking for a significant decrease and you got a positive increase, although it is significant, it's not in the indicated direction. Okay, so you would not accept the research. I mean, you would not accept the null hypothesis, because null hypothesis says there's no difference. So that's false. But in terms of the research hypothesis, you would accept it with certain wording specifying that even though there is a significant difference, wasn't in the predicted direction. Okay. So some hypothesis testing FAQs we've talked about a lot. Talked about how do you go about selecting a critical region boundary, talking about what it means, what two pieces of information you need, why is the critical boundary region important, how are z-scores that are used for critical boundaries obtained, and we also talked about how you go about making decisions in regard to hypothesis testing. So I'm hoping that this video, in culmination with your textbook reading and questions that you're asking in class, and utilize my office hours, I'm hoping that this will help your understanding and foster your development to higher levels. All right. So I'm going to stop now because I know this has been a fairly long video, but I hope it's been a helpful one. Take care.